Question number 7 for the mock exam March 2025, paper 1, 9709/12. Okay, here's the first question. The question 5 states to prove the identity, and cos theta over tan theta times 1 minus sin theta is equal to 1 plus 1 over sin theta. As in the proof, we have only one trigonometric function left, that is sin theta. So we will resolve every other trigonometry into sin theta. So first of all, tan theta can be resolved into sin theta over cos theta, because divisor to divisor. So if I can write cos theta here in the numerator, it is same like that. Divisor to divisor, it will become up. So here in the numerator we have cos square theta over denominator we have sin theta times 1 minus sin theta. So cos square theta can be resolved into 1 minus sin square theta, and this is sin theta 1 minus sin theta. Apply the identity a square minus b square, because 1 square is the 1 time plus 1 time minus, we will get it 1 plus sin theta times 1 minus sin theta, sin theta times 1 minus sin theta. So it cancels. We will get 1 plus sin theta over sin theta. So we can divide it individually, like 1 over sin theta plus sin theta over sin theta. That gives me 1 over sin theta plus 1, and that is the right hand side, 1 plus 1 over sin theta. Hence proved. It's so easy. So part 2 of the question, hence solve the equation. So this is the same as one we proved it. 1 plus 1 over sin theta is equal to 4, and the domain of the angle is from 0 till 360. Here we have 1 over sin theta. 4 minus 1 is 3. So sin theta will be 1 over 3, and it is positive. So add sugar to coffee. So we sin can be here or here. So theta will be sin inverse of 1 by 3. So once you take the sin inverse of 1 by 3, you will get the one of the result. That is in the calculator. Now this time you need to change the calculator mode in degree, whatever is assigned. So it's 19.5 degree, and this is in the first quadrant. The second quadrant, we know it will be 180 minus 19.5. So other solutions become 160.5 degrees. So these are two solutions of angles lying in the first and second quadrant. Okay, here comes the question number 6. The first, second, and last terms in the arithmetic progressions. You are given AP, arithmetic progression. So first term is always A, and second term is A plus D, and the last term is A plus n minus 1 times D. So okay, A first term is given to be 56 here, and the second term is 53, and the last term is minus 22 respectively. Find the sum of all the terms in the progression. Okay, first we need to find the n, how many terms comes to be with this. So this is the given. So if you replace equation 1 in 2, you replace A here from 1, 56. So we get 56 plus D is equal to 53. So D comes to be minus 3. So common difference for this AP is minus 3. Now for n, replace this in 3. A is 56 plus n remain n, and D is minus 3 will be minus 22. We will simplify this. N minus 1 times minus 3 equal to, this goes there to become minus 78. Divided with minus 3 and minus 1 will be 26. So n goes to be 27. Now we can find the first 27 term sums. 27 by 2 times formula we know, a plus l, the last term. Here we can write n by 2. Okay, now n is 27, so 27 by 2, a is 56, and last term was minus 22. You can simplify 27 by 2 times, it will be 34. So on the calculator we can get it 459. This is the answer for this part. Let's proceed now. The first, second and third term of a geometric progressions are, this time you are given a GP, and this first term and second term is AR and the third term is AR square. You are given 2 plus 2k plus 6, then 2k and k plus 2 respectively, where k is a positive constant. Find the value of k. Okay, simple question. So we are given between 1, 2 and 3. We know that in geometric progression the common ratio is same, like common difference same in AP. So we divide 2 with 1. Okay, we can write like this, divide 2 by 1, we get r, because a cancel, 2k over 2k plus 6. And similarly we can divide 3 with 2, we get again r, k plus 2 over 2k. Now you can equate these two values of r, because for the same GP the comma ratio will remain same throughout the sequence. So simplify the cross multiply, 4k square is equal to 2k plus 6 times k plus 2, 4k square equal to 2k square plus 4k plus 6k. I can write it directly, 10k plus 12, so 2k square minus 10k minus 12 equal to 0. Further simplified, divided by 2, 5k minus 6 equal to 0. So we can write the factor k minus 6 and k plus 1 is the factor. So here k can be 6 or k can be minus 1, because it is given k is positive, so this will be ignored. So final answer k is 6. I hope it is clear. Yes, furthermore is second part of the same B part. Find the sum to infinity. We know the sum infinity is a over 1 minus r. After finding k, we have the first term 2 times 6 plus 6, that will be 12 plus 6, 18, and a common ratio from anywhere, 2 times 6 over 2 times 6 plus 6, 12 by 18, 6 2s are 6 3s are. So this we have this is the formula given to us. So S infinity will be is 18 over 1 minus r. 18 3s are 54. Yeah, we get 54. This will be the answer. You can calculate directly on the calculator even. Okay, now here goes the next question, number 7. A circle has a center at the point this and the point this. Okay, it's the same like if we have a circle, you are given the center B having coordinate 5 1 and a point C that is minus 1 comma minus 2. Okay, anywhere, it can be anywhere. Okay, it's not exactly the up to the scale and position. So we need to find the radius r. For r we know BC, the distance will represent r. So this 5 minus minus plus, we will apply the coordinate geometry here because it's taken from coordinate geometry. 1 minus minus plus 2 square, 36 plus 9 will be root 45, or further 9 3 5s are, so we can write even this. This is the r. Therefore equation of circle with center 5 1 and r root 45 is x minus a whole square plus y minus b whole square is equal to r square, that is 45. This is a 3 marks question. Okay, here it goes. B part. The point C is such that AC is the diameter of the circle. Okay, if it is like this, B, and C if it is C minus 1 and it was minus 2, B was given to us, that is 5 1, and AC is the diameter. Suppose we have A here, AC, as AC is the diameter of the circle. Point D has coordinate 5 16. It is okay. Show that DC is a tangent to the circle. DC, it means D will be somewhere here 5 6. Tangent DC is because he is lying over here. Suppose D is here 5 16. AC, A is given to us. This was not C, this was A, right? It was A, sorry, it is A, and AC is the diameter to the circle. AC, it means C is if C is 4, okay, C is 4 here, A is if here, minus 1 minus 2, and this makes this diameter of the circle. So I show that DC is a tangent to the circle. For the DC tangent, we know the gradient of DC should be multiple with the gradient of AC equal to minus 1. This we can prove. So for this reason, we need to find the the coordinate of this C first. As C is lying exactly as the diameter, so B is lying at the mid of it. So using midpoint formula, using x y, using midpoint formula, as x for x coordinate it will be this, for y coordinate it will be this. It will be given in the formula sheet as well. So I will get C coordinates for x coordinate of C like AB. X is here 5, is A minus 1 by 2, 10 is equal to A minus 1, so A will be 11. So x coordinates of C is 11, and similarly we can go for y. 1 is equal to B minus 2 by 2, so 2 is equal to B minus 2, so B will be 4. So coordinate of C are 11 comma 4. So this is the one of the coordinates. Now with the help of this coordinate we can easily find the gradient. So the gradient of DC will be change of y, ratio change of y to change in x. So 16 minus 4 over 5 minus 11, 12 by minus 6 will be minus 2. Also we can have gradient of AB or AC because they are collinear, so anyone is fine. AC, okay. 4 minus 1 plus 2 over 11 minus 1 plus 1, it will be 6 by 12, 1 by 2. Since gradient of DC times gradient of AC results minus 1, because minus 2 multiplied by 1 by 2 will be minus 1. So hence we can say DC is a tangent to the circle. So we have proved it. Okay, fine. Next question of C. Here it's I wrote this. This is 2 marks question. Simple case of symmetry. The y coordinates of E is here we have to find. and the other point, other tangent, another tangent T from touches the circle. The figure is not done on the exact scale, but roughly it is drawn. So we can have this. So first find, say we suppose B is E. E coordinates are AB and C is the same. By symmetry, we know the coordinates of E is the same as the coordinates of C, because we know the tangent drawn on a circle, right? Two tangent drawn on circles are equal in length, as the properties of circle we know. So this is same as this. So as it is how much away from any 11 minus 5 is 6. So vertically and horizontal, vertically it is 4 units, they are on the same level. So B can be supposed as y coordinates of the coordinate E will be 4, and for the x coordinates, here we can say if this is the radius is 5, so it can, and the difference of 11 to C to D from 11 to 5 is 6, so 5 minus 6 can be -1. So we can see coordinates of E are, because radius bisects the chord CE, so by using symmetry we can say our x coordinate is -1. So coordinates of E are -1, 4. I hope it is clear. It's only theoretical concepts, 2 marks, we don't need to go with the detail. Okay. Here question 8, the function f is defined as follows. F of f5. So first find f of 5 here, because this is 5 plus 3 over 5 minus 1, 8 by 4, that will be 2. So f of 5 means f of 2, because f of 5 is 2. So now it will be 2 plus 3 by 2 minus 1, that is 5 by 1. So f of 5 goes to be 5. This is the 2 marks, easy question. Okay, find an expression for f inverse. And so we can write it simplified, taking f of x as y, cross multiply xy minus y equal to x plus 3. As we know, we need to make the x as a subject here. So xy minus x will be y plus 3. So x is common, y minus 1 is equal to y plus 3. So we have done the x as a subject. So that is the final result. So this means inverse of this will be x plus 3 over x minus 1. And its domain will be for the same as, because it should be greater than 1, because at 1 it will not be defined. Yes, here in question number 9, it is volume of a solid cylinder. Okay, circular cylinder of radius. This is like a circular cylinder. Okay, so volume is 250 pi centimeter cube. Show that the total surface area, okay, total surface area of cylinder is denoted by S, is 2 pi r square, because here pi r square and pi r square, pi rh and pi rh, so it's the height. So plus 2 pi r h. So we have to find this one in this form. And here in this proof you can see there is no h. So from given information that you are given volume of cylinder, that is pi r square h, that is 250 pi equal to r square h, pi r square h, pi cancelled. So we get h is equal to 250 over r square. Now replace h with this. We get 2 pi r square plus 2 pi r, and h is 250 by r square. So s will be 2 pi r square plus 1 r will be cancelled with the denominator. We get 250 times 2 is 500 pi by r. Hence proved. This is so simple 2 marks question, as a gift. Given that r can vary, find the stationary value of s. For stationary value, you need to differentiate with respect to r and equate to 0. So ds by dr will be 4 pi r minus 500 pi over r square. You know how to differentiate it, because this r can be written as r power minus 1, and you can differentiate this and equate to 0 to find r. So 4 pi r is equal to 500 pi by r square. So cross multiply, we get 4 pi r cube is equal to 500 pi. So r cube will be 500 divided by 4, pi cancelled, and after cancellation we get r cube is equal to 125. So r is equal to 5 is in centimeter, so centimeter. Given or find the stationary values. Stationary values of this, for the stationary values, we just replace s is equal to what, 1 in s, as with 2 pi r is 5 square. In this first part proof, we need to replace it, plus 500 pi over r is 5 in the calculator, and we can simplify it to get 150 pi, or 136 point something. In the calculator we can say 150 times shift pi, and we can write 400 and whatever comes, that's your answer, right? Even you can write your answer in centimeter square, because s is area. Determine the nature of the stationary point. For nature of stationary point, you need to differentiate again. So d2s by dr square will be 4 pi minus plus 1000 pi by r cube, right? You know how to differentiate. If you are weak in differentiation, you can check that with my video on differentiation. Specifically, there are 2-3 videos on basic concept, you can revise it. And with this, at r is 5, we know that d2r by d of this r square at r is equal to 5 will be 4 pi. It seemed to be positive, yeah, it is all positive, so it 100% will be positive. That will be greater than 0, mean positive. Therefore d2s by dr square is greater than 0, mean the nature of stationary point is minimum. I hope it is clear. Okay, now this is the last question of this paper. Yes, no more. Last question of this paper. In this question, the diagram shows the part of the curve root y equal to 4 square root x minus x. The curve has a maximum point at M and meets the x-axis at O. Okay, at O and A. At x-axis, we know this. We have to calculate the coordinate of A and M. First, we find x-axis. Y coordinate is 0. So 0 is equal to 4 root x minus x. So 4 root x will be x. 16 x will be x square. So we can write x square minus 16x equal to 0. So x or x minus 16 will be 0. So x either be 0 or x either be 16. Because here it is very much clear that A is away from the origin. So the coordinates of A will be 16 and 0. So A will be 16 and 0, because at origin 0, 0. Now for the coordinates of y, that is the it's the maximum point, is given there for m, coordinates of m, that is at maximum point. So we find dy by d of x, that is 4 into 1 by 2 x power minus 1 by 2 minus 1. So dy by d of x 2x power minus 1 by 2 minus 1, and that should be equal to 0, because at maximum point dy by dx is 0. So 2 over root x, because minus 1 by 2 minus 1 equal to 0, so equal to 1. So root x will be 2, so x will be 4. So x is seem to be 4. So if x is 4, what will be y? Do replace in the function. Y equal to 4 root 4 minus 4. 4 times 2 minus 4, 8 minus 4 is 4. So y is 4 as well. Therefore, maximum point is 4 comma 4. So it means here in the figure, if y is 4, x will be 4 here. So this is the solution of this question, 5 marks. Paper seemed to be very easy. Yes. Its next final part, find the volume obtained when the shaded region is rotated 360 about the x-axis. Okay, for x-axis, term in the answer in term of pi, we know that volume of shaded region is pi a to b y square d of x, as y is given to be this. So y square will be, first we need to solve this. It's better to solve here separately. A minus b we can write 2 times, or apply the identities. It is 16x plus x square minus 8x power 3 by 2, right? So I will replace this here, pi, and the limit is 0 to 16, you know well, 0 till 16, because x-axis is 0 and 16. Yes, true. 0 to 16. Y square is 16x plus x square minus 8x power 3 by 2. We will just integrate it, apply the basic principle of integration. I will get is 16x square by 2 plus x cube by 3 minus 8 times x, it will be added 1, so it will be 5 by 2, and here 5 by 2, and 0 to 16. Now apply the values, or further simplify. 8x square plus x cube by 3 minus 16 by 5 x power 5 by 2, 0 to 16. So here you can see in all the 3 terms we have the variable x. So once the lower limit will be 0 automatically, just replace the upper limits. Pi will be, that will be 8 into 16 square plus 16 power 3 by 3 minus 16 by 5, 16 power 5 by 2. Upper limit minus lower limit will be 0, so no need to write it. So save the time, and with the calculator we will get it 136.5 pi, because said in term of pi, or you can write it 137 pi. That is the final answer. I hope it is clear. Good luck for the upcoming exam, and inshallah I will solve more practice question for you before you go to the CIEs. Inshallah it will work. Do revise all the concepts once again, and keep solving maximum questions from the past year paper to get good grip on the concepts. Good luck, guys.